So yeah, again, thanks Harsh for the info. Really amazing to see all the progress that's happening in LocalStack. Big kudos to the team. So one thing that I want to briefly share today is something that we've been experimenting with essentially over the last couple of months, as Harsh already mentioned, which is a new step towards a Snowflake emulator. So first of all, what is Snowflake? Snowflake is a cloud data platform that allows for scalable data processing. So you can do things like uploading files in different formats, CSV, JSON, Parquet, and others. And then you can basically run SQL statements over these files. So you can basically create tables in databases and insert the data from these files into tables and then run selects over them, for example. But there's also much more. So there's also things like scheduled jobs if you want to create things like ETL pipelines and so on. So it's a fairly sort of elaborate platform for running data jobs and data pipelines. It also has lots of different integrations with SDKs and tools to interact with the platform. So things like Pandas data frames, Snowpark libraries, JDBC driver, and so on. And we'll see a bit more about that in just a second. There's a certain similarity to some of the big data services in AWS that we are already providing. So things like Athena, for example, for querying SQL over S3, Redshift, EMR, Airflow, and so on. But it's really like a very comprehensive data platform where you can run your data workflows. Now, the reason why we were interested in this because it looks like there's also a need in the community, or at least some requests on is there a local development story for Snowflake? So we've come across a couple of forum blog posts and things like Stack Overflow posts where folks were asking, okay, is there a way for us to run some of these Snowflake workloads on the local machine? It's not something that's currently available by the vendor, so we sort of set out on this journey to create a first version of that. I think the challenges we want to solve with this is similar to what we're doing in AWS and the AWS cloud, right? So speeding up development cycles, avoiding resource conflicts, having reproducible tests, and so on. So I think relatively similar story, but then the data space obviously has some specific challenges also to it, which are interesting for us to explore. So in a nutshell, this is a first beta version of this emulator that we're gonna showcase today. It can be easily installed either as an extension in LocalStack in an existing container or as a separate Docker image that we provide. It's currently in private beta stage, so please get in touch with us if you're interested in trying this out. And what we do is we basically emulate the actual Snowflake API surface to provide the same functionality as a real Snowflake system, which then allows you to bring your own tools, things like a JDBC driver or a database visualization tool, like we can see here on the right-hand side. And we'll see this in just a second in the live demo. And the same thing applies also to what we're doing with the AWS emulator. It's fairly easy to extend your local setup also to a CI pipeline and have repeatable tests and a setup that is really easy for you to take with you, a portable sandbox, if you will, that runs Snowflake. So this is a list of the features that are currently sort of supported in different levels of parity and fidelity, I would say, but definitely adding more by the day. So we can create things like warehouses, databases, schemas, and tables. So sort of basic sort of data manipulation there. We can store files in stages. We'll actually see how that works with our internal S3 implementation, which later also feeds into Ben's second part of the meetup today. You can use things like Snowpark libraries or a Kafka connector if you have some streaming use cases. And there's a bunch of other features like, for example, user-defined function if you have something like a JavaScript or a Python function you want to execute. And there's a bit more, and we'll go through these as part of the demo as well. This is maybe I'm not going to go through this in much detail here, but it's basically showcasing, what we'll see in the live demo in just a second. Basically, on the left-hand side, running the Snowflake container, and then on the right-hand side, we'll just step through a couple of select and insert queries and so on. But again, we'll just see this live. I think it's much more interesting than watching the video, but we also have this on YouTube if you're interested to take a look later on. So one thing to maybe mention briefly is we're also looking to integrate this Snowflake emulator with our existing cloud tooling and the cloud platform. So one feature that we're quite actively developing, and we've shared this in some of the previous community meetups, is Cloud Pods. So it's basically a way to store a persistent state of your LocalStack container and then easily share it with your team members, right? So you can use this to push the state of your container, push it to a server, someone else can pull it down, and then recreate the exact same state on their local machine. And we'll also showcase briefly what this looks like with Snowflake. Again, I think it's really interesting from this collaboration and sharing aspect to deal with the state in your container in a very easy and flexible manner. And again, we'll cover this also in just a minute in the live demo. All right. So with that, I think I'm actually already sort of ready to dive into the demo. So it was just quickly to set the stage. So from here onwards, I want to walk through a couple of smaller samples to showcase different features and functionalities. It's going to be 5 short demos, and those will hopefully give you a bit of an overview of what's available in Snowflake. So the first one is, let's just start Snowflake and run a bunch of basic queries, right? Basically similar to what we saw in the video just before. So I'm switching over to my terminal here and just clearing out all the sessions here. I'm starting up LocalStack in a container, so that's something that's familiar to most of you. And this container that I'm running here already has the Snowflake extension enabled. So if I do a Docker PS here, I can see that the container is running with our typical configuration. So it's the same as usual, port 4566, our canonical gateway entry point, which we also use for Snowflake here. And now it's basically up and running, and we can start using the tool. So I'll switch over to my dbeaver here, which is a database visualization tool. And let's just take a quick look here how this connection is configured. So we can see we just basically pointed this dbeaver here to Snowflake localhost, which is localhost of LocalStack Cloud, which resolves to a local IP address, and we have just a test username and test password. So this is just the way how to configure the JDBC driver in order to talk to the local Snowflake. And now, sort of really as the very simple first getting started, we are sort of running a bunch of steps here, right? So first of all, I'm executing a create table statement here. As you can see here on the left-hand side, the container is now sort of spinning up and it's doing a bunch of processing. And now we see that the table has been created. We can now continue and step through this. So just insert some data, some values for Bob and Alice. And then we can query, we can run selects against this table. And then we can actually see the output here as well. I hope this is actually sort of large enough in terms of the font size. So this is really just the very most simple hello world we can do, right? Creating some tables, adding some data, and running selects on it. We can then also use JavaScript functions, for example, right? So we can create a UDF that we just create, we call it func1. And this function will basically just return hello with an input value that we can provide. And if we call this function here, it basically gives us the result hello world, unsurprisingly. So yeah, this is really a very simple first way into what this looks and feels. You can again interact with it from the local machine. There's no outbound connectivity whatsoever to real Snowflake as we go through this demo. Okay, so this was really the most simple getting started, demo 1, and with that we can sort of switch gears a bit and look into some more more advanced examples. So first of all, Snowflake has a bunch of quick start guides getting started. This pretty nice tutorial style intros where you can download some data sets, run some queries over it. And one of them I wanted to briefly show is a COVID-19 vaccination data set that I think is used quite frequently also in the data science community for just showcasing different functionalities and data platforms. And this data set contains different data entries for mobility of patients, vaccination data, and so on. And for this example, we'll just focus on downloading some of these CSV files, putting them onto a local S3 stage. So stages are the place where files get stored in a Snowflake context. And we use our own internal S3 implementation for that. And much more will be shared later by Ben in the second part of the meetup. We're then going to load this data into a local table and run a bunch of select queries over it. So relatively straightforward, but really kind of following a bit the steps of what's already provided in these samples here. So I'll switch over here, just basically, starting from a fresh instance. So I'll just restart my LocalStack Snowflake here. And now we can get going with some of the queries in this example. So first of all, and I'm just going to copy paste this for the most part here. So this is my notes here. First of all, we're going to create a stage called S1. So a stage is basically the place where files can get added. Files from the local file system can get added into the Snowflake system. And then we're going to run a query that basically does a put operation. So put is really the operation that takes a file from a local directory. So in this case, it's just a /gmp and uploads it to the stage. So this is just doing the put operation, and we can now see that this particular CSV file has been uploaded. And now we can actually start interacting with this. And as I mentioned before, these stages use our local S3 implementation. So I can now do an AWS local S3ls, like listing the contents of this bucket, and we'll see that it has been uploaded here. And what we can do now is we can now copy that CSV file that is on the stage into a table, right? First of all, we create a table. So by the way, I think for that, instead of using the terminal here, I can also switch over to my dbeaver again. I think it might be a bit easier to follow along here. So what I'll just do is it's just the same queries that we saw over there. So we first create a table with the basically the schema of these data files. So it contains the jurisdiction, some timestamps, and allocations for vaccines. How many doses basically were allocated to different parts of the country in the US. And then we can copy this data from the stage using a copy into command into the table. And then once that's done, we should be able to now run some queries over that data. We just do a select star from COVID-19 with limit 10. And we can already see here, and again, I hope that's visible on the screen. We can see this jurisdiction, which is basically the state in which week the allocation was taking place, and how many doses for 1 and 2. So this is kind of really stepping through some simple queries in terms of how to get data into a stage, stored in a S3 bucket locally, and then sort of running some queries over it. There's also, just copy this one query from here. If you want to do something a bit more sophisticated, we can also do a query that is doing a grouping by jurisdiction and just doing a count over all the doses. So if we just run this here, it should give me essentially for the different states how many doses they actually allocated in total in the first allocation. So you can see California is in the lead, Texas and Florida following after. So again, kind of showcasing relatively simple way to use local files in the local directory, in the local file system, updating them to a stage. The stage again is just an S3 bucket running inside LocalStack on your local machine, and then you can just use these regular queries to interact with that data. All right, that was already the wrap up of this demo 2, and again, really want to just browse through a couple of these different demos here to show different parts of the functionality. The third mini demo we want to briefly showcase is a Citybike trips dataset. So this is again coming from the Getting Started guides in Snowflake. This time, slightly different dataset. This is from the New York City Citybike system, where they provide public information about mostly trips. Which trips were happening at which point part of the day. And then also with some seasonal weather information, basically, at which season was that happening, what was the weather at that point in time, which can be interesting to correlate how many trips were happening during which weather conditions, for example. Again, so this is something that is provided as an application actually by Snowflake, and we were just basically cloning one of the applications that they provide here. So again, what I'm going to do, switch over here. I always just, as a habit, start with a fresh instance, and let's focus on our sample 3 here. So I'm first going to a different directory here. So now I'm in this directory, which has the code checked out that is provided also in the GitHub repository provided by Snowflake, and this contains a bunch of queries and also a small web application that we can then open up and kind of illustrate and visualize that data. Okay, so I'm just again copy and paste some of these commands here. So the first thing we're actually going to do is to look at this data, and that's actually available in a public S3 bucket. So I'm just making an S3 ls command here with --no sign request. So it actually calls out to real AWS to list the files in this bucket. So we have a bunch of weather data here and trips. So these are all CSV files that are gzipped. So the interesting part now about this demo is also that, so we're gonna create a stage similar to what we did before, right? So we have this create stage demo data commands. But in this particular case, we're not gonna use a local folder, but we're actually pointing to the actual remote public S3 bucket, right, from real AWS. So that is one of the capabilities that we built into this Snowflake emulator, that you can also either use the local S3 implementation, or you can also import data directly from remote S3, right, from the real AWS cloud. So we've created this stage now. The next thing we can do, just making sure I'm copying the right commands here. So we just created the stage, and the next step would be to create the table, right? So the table will be used to store the trips. I think I need to make sure that this is actually not copied properly. Okay, so this is creating a table called trips, and trips just has things like the duration, start time, which station, which bike ID, and so on, user type, and so on. So that's the basic information here. Then we can create then we actually copy the trips data from the stage into that table, which is created, right? And I realized that maybe it's actually better to even go back to my dbeaver here again, because it's a bit tricky to do this from the terminal. But let's just do it here. So what's happening now we're copying the trips data, and this was actually reaching out to real AWS to download this file and put it into the table, right? So this is a pretty seamless integration here. And the other queries I'm actually going to run from here because it's a bit easier. No, I don't have it here. Okay, so I have to run it from there. So we created the trips. Then the next thing is to create the weather table. Okay, so weather has a bunch of additional information here. So whether there was snowfall, we know what the max temperature was here, minimum temperature. So this is just a bunch of the schema basically for the weather data we're then gonna import. So we just created the weather table, and then the last step here is to copy the weather information into that table. So just going to do this copy into weather, and we're again referencing this stage that we've created beforehand. Okay, so the data has now been bootstrapped basically, and what we can now do is we can fire up the a web application that comes with that. So it's just an npm start, which has a small, basically local API server and a web application, which we can now open on port 3000 in my browser. And I'll just go here real quick, and I'm refreshing this page, and what you can already see is this application. It's now loading the trips data, and you can see this distribution, for example, in which month we had more trips. It looks like September, October are pretty popular months for Citybike trips. Also the weekday distribution, and what's at which temperatures cyclists enjoy cycling the most. So it's interesting distribution here. I'm not sure why 30 degrees Fahrenheit is not a good temperature for cycling, but 20 degrees is. But yeah, so this is apparently what the data gives us. And we can also do some different years here. I think we can select some time range to go, for example, to 2019. We can update, and it's basically gonna run another query in the background, and we'll update the data here. So you see that it has maybe 2, 3, 4 seconds of lag. So this is really sort of the computation that's happening in the background here. I think we have a couple of 100,000 entries in these tables, but it's just processing them on the local machine and then displaying the information here. All right, so that was the sample number 3, and then just really browsing through just two more short samples. So one of them is table streams. So table stream is basically a way to enable change data capture for Snowflake tables. So whenever you add some records to a table, there is separate. You can configure a stream table that records all the changes happening in the table, so inserts, updates, deletes. There's some more information here on this website in the user docs of Snowflake, so we don't need to go into too much detail. But then basically this is something that we've also started implementing in the first version. And you can then consume these stream records from the stream table by doing an insert into with a select from statement. And again, we can just briefly step through that. I think I have that available in the in dbeaver again. So just as usual, starting with a fresh instance, just in case. Moving over to my dbeaver here, and I'm just really gonna step through these real quick. So we first create a table called members. So this is basically a gym membership table where we just create some synthetic gym member entries. So we first create the members table with just an ID, a name, and a fee. Then we create a stream on that table. So that stream is called the members stream. So this now really sort of creates a separate virtual table that observes any updates on the members table and puts the records into the members stream. So now if we insert some actual values into the members table, which we've done here, so we're inserting 5 different members, and now we can actually query the stream table, right? And that gives us the insert actions for these 5 entries that we've done before. There's also this row ID, which gives us a unique ID for each row. And this is really the content of the stream table here. Okay, so we can select the content of the stream table. In addition, we can now also copy the contents from the stream table into a new table, right? So this is a common ETL pattern where you want to, copy data from a source table into a target table. And that's what we want to do now by creating a members copy table. So that has the same schema as the original members table. What we can now do is we can copy all the records that are in the stream table into the target table, right? So this is done by an insert into with a select from the stream, right, where the action was insert. So I'm just going to do this here real quick. So we did the insert, and now we've actually copied the records into the target, into the members copy. So we can see the same details here. And one of the interesting observations now is, and this is just the semantics of how it works in Snowflake, the stream table should now be empty because we've actually consumed the records by doing an insert into a target table. So if we do another select on the stream table, it's now actually empty because all the records have been shuffled over into the target table. So yeah. Again, relatively quick walkthrough here, but I think it maybe becomes more clear, or those of you familiar with stream tables can probably follow this example. And there's much more docs about the exact semantics on how this really works with the stream tables. Okay, so I was looking a bit at the time. I think I can dive into the last quick demo. So this is a really integration with CloudPods. So what we, as mentioned before, we want to provide the same functionality that we also offer for the AWS emulator and all the different services for Snowflake. And one of the things is CloudPods. And for that, let me just quickly switch over to our web UI, which is basically the entry portal into a lot of the functionality you can get with LocalStack in general. And one of the sections you'll find here on the left-hand side is CloudPods. I can then select show only my own pods. And we've prepared some simple pods here that I want to quickly inject now into my instance, right? And then see what kind of data is in there. So I've created this one pod called pod Snowflake, and just quickly restarting the instance here. Starting up, and can terminate this here. And so what we can do now is we can use the LocalStack CLI, and we have this command called pod load. There's pod save to create a pod, and pod load is the operation to load an existing pod into your instance. And we can now run this, and this is of course something with the license file. I think there's already seen this before, so this should hopefully fix it. Yeah, just had some caching issues there. So I'm now loading the pod into my local instance, and this, as you can see on the left-hand side, already spins up the Snowflake information here. And now we can do a select on a me see. I think it's a table called test. So we pre-created the table called test in that pod. We can now do a select from it, and it shows us hello from LocalStack Snowflake. So again, this is a way to easily package up your state that is in an instance in a container, and then share it easily with your team members and do collaboration with it. All right, so I think that was really it from the demo part. Let me switch back to my slides. So to wrap up, so what we're trying to show here is we're basically experimenting with new features and functionalities in the data engineering space specifically. So we can take a lot of the learnings and the strong foundation that we have in the AWS emulator and apply that to building tooling to test your data pipelines locally. So this version of what you've just seen is still pretty early stage, but the direction looks pretty promising, and we'd love to get your feedback. So if you want to participate in our beta program, please do get in touch. And as also illustrated, it nicely integrates with our existing tooling and features. So the local S3 implementation, which we'll see a lot more about in the upcoming minutes from Ben from our team. And then we're also working on integrations, with other AWS services. For example, Kinesis Firehose has a way to put streaming data that is going through a Firehose into a Snowflake target, and we can really leverage also the integrations here between AWS and Snowflake and provide this unified platform locally. And also, as mentioned, Cloud Pods is something that we really are providing here, and it allows you to save and load the state of your pods. So we're also anticipating some interesting challenges there related to testing more broadly in the data space. Things like test data management. How do you test ETL pipelines in CI and so on? So very much looking forward to getting your feedback also on how to approach this topic and which particular challenges you're facing there. And with that, I'd like to wrap up and take some Q&A if we have some.